For most of the time our species has existed, food was eaten raw. Meat was torn from bone without fire. Roots were pulled from earth and consumed as found. Fruit was picked and eaten in the moment it was discovered. There was no preparation. There was no waiting. There was no transformation between the moment food was found and the moment it was consumed. The human body, in its earliest form, was shaped in environments where flame was rare, accidental, and not yet controlled. Yet something changed. Somewhere in the long and quiet arc of prehistory, fire moved from being a force of nature to a tool of survival. It moved from the periphery of daily life to its center. If our biology was formed in a world before cooking, what does it mean that cooking may have made us who we are? What does it mean that the brain capable of asking that question may exist partly because of a flame first noticed burning in a field of dry grass after a distant storm? Why did humans ever start cooking food? For most of the time that humans walked the earth, there was no hearth waiting at the center of daily life. No fire tended through the night. No meat held over flame until its texture softened. Early hominins consumed what the environment offered in the state it was offered. The transformation of food through heat was not inevitable. It was a discovery that, once made, quietly altered the entire trajectory of human biology and human life. To understand why humans ever started cooking food, we must begin not with a single moment of invention, but with the landscape that made such a discovery possible. Lightning strikes ignited grasslands. Volcanic activity produced heat and flame in certain regions. Early hominins would have encountered fire as an environmental event, something dangerous, something powerful, something that changed the landscape and the animals within it. The relationship between early hominins and fire was likely one of cautious observation long before it became one of use. Animals fleeing wildfire, cooked seeds and tubers left behind in burned areas, the smell of charred meat from animals caught in grassland fires. These encounters would have preceded any deliberate act of cooking by enormous spans of time. The mind that eventually chose to hold food near flame did not arrive at that choice immediately. It arrived after generations of watching what fire did to the world around it. The transition from observing fire to controlling it was not sudden. It unfolded across a span of time so long that no individual life would have witnessed more than a fraction of the shift. Some sites in Africa contain burnt bones and thermally altered sediments dating back nearly 1 million years or more. The evidence builds slowly, site by site, layer by layer, across a vast stretch of time. By the time of Homo erectus, there is increasing evidence of association between hominin activity and fire. Sites in Africa, Europe, and Asia from this period show recurring patterns of ash, charred bone, and fire-altered stone. The evidence does not all point in the same direction simultaneously. It builds slowly across a vast stretch of time. What is clear is that fire was becoming a regular part of hominin life, rather than a rare or accidental encounter. Among all the gifts fire provided, perhaps the most quietly transformative was what it did to food. When animal flesh was exposed to sustained heat, proteins unfolded. When roots were placed in ash, starches broke down. Tough, fibrous plant material softened. The caloric return from a given quantity of food increased significantly when that food was cooked rather than consumed raw. This increase in caloric yield was not simply a convenience, it was a biological event. A body that could extract more energy from the same raw ingredients had a measurable advantage in environments where food was uncertain. Over time, the regular consumption of cooked food would have altered the demands placed on the digestive system in ways that left permanent marks on human anatomy. The margin between survival and failure was often narrow. Cooking shifted that margin. To understand why humans ever started cooking food, it helps to understand exactly what fire does at the level of chemistry and structure. Raw meat contains protein folded into complex three-dimensional shapes. Heat unfolds those protein structures, exposing them more completely to enzymatic action. The body does not have to work as hard to extract the same nutritional content. More is yielded from less effort. Raw starch exists in dense, tightly packed granules that resist rapid digestion. When those granules are exposed to heat in the presence of moisture, they absorb water and swell. Their tightly organized structure breaks down. The result is a softer, more open molecular arrangement that digestive enzymes can act on quickly and efficiently. Cooked starch is absorbed significantly faster and more completely than raw starch. Many wild roots, seeds, and legumes contain compounds called antinutrients. These include tannins, lectins, phytates, and enzyme inhibitors that reduce the body's ability to absorb minerals and proteins. They exist in plants as natural defenses against being consumed. Cooking degrades or destroys many of these compounds, making plant foods significantly safer and more nutritious. A diet that incorporates cooked plant material is chemically different from a diet of raw plant material. Among the most striking features of human anatomy, compared to other great apes, is the size of the brain relative to the body. The human brain is metabolically expensive. It consumes a disproportionate share of daily caloric intake. It demands a continuous and reliable supply of energy, even during sleep. Maintaining such an organ requires not only that food be available, but that the energy within it be accessible efficiently. The cooking hypothesis proposes that the shift to cooked food provided the caloric foundation necessary for brain expansion. A smaller gut, no longer required to process enormous quantities of raw plant matter, freed energy and physical space. A more calorie-dense diet supplied the sustained fuel that a larger and more complex brain required to develop and maintain itself. This was not a decision made consciously by any individual. It was a slow convergence of biology and behavior across hundreds of thousands of years. The physical evidence of this shift is visible in the fossil record. Homo erectus, associated with some of the earliest consistent fire use, shows a reduction in tooth size and jaw structure compared to earlier hominins. Smaller teeth suggest that food was being mechanically processed to a greater degree before it even entered the mouth. These anatomical changes did not appear randomly. They appeared alongside evidence of fire. The human intestinal tract is shorter relative to body size than that of other great apes. The large intestine is proportionally reduced in humans compared to our closest relatives. This reduction is consistent with a diet that contains less raw fibrous material requiring extended fermentation and more cooked food that has already been chemically simplified before digestion begins. These anatomical differences represent structural adaptations that accumulated across many generations of consistent cooking. The stomach also shows signs of this adaptation. Human stomach acid is unusually strong compared to many other omnivores and even some carnivores. It helps sterilize food and break down the proteins in cooked meat more efficiently. The chemistry of the human digestive system reflects a long history of cooking rather than a recent adoption of it. Humans produce more copies of a gene encoding salivary amylase than most other primates. Salivary amylase begins breaking down starch in the mouth before food even reaches the stomach. The duplication of this gene suggests that starchy cooked foods became a stable and significant part of the human diet far enough back in evolutionary time to leave a measurable genetic signature. The body did not simply tolerate cooked starch, it adapted its chemistry specifically to handle it. To understand why humans ever started cooking food is, in part, to understand that the question eventually reverses itself. The body adapted so completely to cooked food that cooking stopped being a useful innovation and became a biological necessity. The digestive system that developed alongside cooking is less suited to a fully raw diet than it once was. The human body became dependent on fire's help in ways embedded in its very structure. These anatomical differences are not trivial. They represent structural adaptations accumulated across many generations. A body that regularly receives cooked food does not need the same digestive infrastructure as one processing raw material. The investment in tissue and the energy cost of maintaining a large fermentative gut can be reduced without consequence when the same food arrives pre-processed by external heat. Over evolutionary time, the body adjusted its architecture to match its inputs. Beyond the biological transformation, cooking introduced something else that is harder to measure but no less significant. The hearth created a center. Fire required tending, attention, and a degree of stillness. It created a condition that mobile, dispersed foraging did not easily produce. It brought individuals together in one place after the day's searching was done and held them there through the evening hours. Gathering around a shared flame altered the structure of group life in ways that extended far beyond the preparation of food. It created a time and a place for sustained proximity, for extended communication. Around a hearth, individuals could remain together for hours. They could observe one another. They could engage in the kind of continuous social interaction that strengthens bonds over time. Sharing food that had been prepared required a degree of mutual confidence. Distributing cooked meat implied cooperation that extended beyond the immediate act of acquisition. The hearth, in this sense, was not only a kitchen. It was among the earliest forms of a shared social space in human history. The activities that gathered around it built the fabric of daily cooperation within groups. The conversations held around those fires, the transmission of knowledge from older individuals to younger ones, the organization of roles and responsibilities within the group, all of these were deepened and enabled by the habit of gathering in a common place as light faded and movement through the landscape became less practical. Children learning around a fire, elders describing landscapes they had traveled, hunters recounting the behavior of animals observed during the day. These exchanges built the accumulated knowledge that allowed groups to navigate complex environments across generations. The fire did not cause this knowledge to exist, but it provided a regular occasion and a settled context for it to be shared, refined, and passed forward in ways that scattered mobile foraging could not easily support. Language itself has been linked by some researchers to the conditions created by fire. The development of complex spoken communication requires not only the physical capacity for speech, but also the social conditions that make extended vocal exchange useful and habitual. A group constantly in motion has fewer sustained opportunities for the kind of long, complex verbal exchange that deepens linguistic capacity over time. The quieter, more cooperative, more settled setting of firelit evenings may have created conditions favorable to extended vocal communication. Around a hearth after dark, there was no immediate task demanding silent concentration. There was time, there was proximity, there was the shared experience of warmth and light surrounded by darkness, a boundary that encouraged inward focus and togetherness. Stories told around fire would have carried information about the landscape, about dangers, about the behavior of animals. This information, transmitted verbally across generations, would have functioned as a kind of accumulated external memory. It extended the knowledge available to any individual far beyond what that individual could have gathered through direct personal experience alone. Whether or not any specific claims about fire and language can be proven with certainty, the broader point remains significant. Cooking transformed the social structure of daily life. It introduced a fixed point, a regular gathering, a shared activity with shared outcomes. These features created a context in which human social complexity could develop in directions that scattered, purely mobile foraging might have constrained. As human populations spread across Africa, into Eurasia, and eventually across the globe, fire traveled with them. The environments that humans eventually occupied included landscapes that a tropical primate body was not naturally equipped to survive. Glacial Europe, the cold steppes of Central Asia, the wind-scoured margins of Ice Age Siberia. None of these environments were accessible to a body that depended on warmth from its surroundings and relied on raw food for its nutrition. Fire changed this calculation. With fire, warmth could be carried into cold landscapes rather than derived from them. With cooking, food sources that would be dangerous or insufficient when raw became viable. The range of viable environments expanded, not because the human body changed to suit those environments, but because fire changed what the body could do within them. Archaeological sites from widely separated regions and time periods all preserve evidence of fire use. There are no known human populations anywhere in the world that entirely lack cooking as a cultural practice. This consistency, spanning every environment humans have occupied across every continent, points towards something fundamental. Cooking is not a regional tradition that spread through contact and imitation. It appears to be a feature of what it means to be human. In cold northern environments, fire was essential for survival in ways that went beyond food. It was the difference between inhabitable and uninhabitable. Without fire, the metabolic demands of maintaining body temperature in freezing conditions would have outpaced what any available diet of raw food could supply. With fire, those demands could be met. New landscapes opened. The materials and methods used for cooking varied enormously by region, time, and available technology. Open hearths built directly on the ground, stone-lined pits filled with heated rocks, earth ovens covered with leaves and soil trapping steam within, clay vessels that held liquid and allowed boiling at controlled temperatures. Each of these represented an adaptation of the same basic principle to the materials and conditions of a particular environment. Heat transforms food into something the human body handles more efficiently. That principle required no universal invention or single point of origin. It could be discovered, lost, rediscovered, and refined independently in different places at different times, because it works, because the body that discovered it benefited from it, because the groups that practiced it consistently had access to more usable energy from the same landscape than those who did not. In coastal environments, cooking transformed marine foods. Raw shellfish can harbor pathogens that heating destroys. Fish cooked over flame provided protein in a form safer for consumption and more efficiently digested. In grassland environments, cooking large game animals maximized the caloric return from each successful hunt. In forested environments, cooking opened up a wider range of plant foods, including those that would be inedible or harmful when consumed raw. The diversity of cooking methods across human cultures also reflects the accumulation of knowledge about how heat interacts with specific foods. Smoking preserves food through chemical processes that inhibit bacterial growth. Different cooking temperatures produce different results. Dry heat produces different chemistry than moist heat. The human relationship with the transformation of food outside the body is not limited to fire, but fire was where it began. Cooking also altered the relationship between humans and their environment in ways that eventually made agriculture possible. The ability to process grains through heat was not peripheral to the agricultural revolution, it was central to it. Many of the staple crops that formed the foundation of early agriculture are not easily consumed in large quantities in their raw state. Cooking transforms them into the accessible, calorie-dense foods that could sustain large settled populations. Before agriculture, cooking had already expanded the range of plant foods that hunter-gatherer groups could safely and efficiently consume. Wild roots, seeds, and legumes that were nutritionally valuable but chemically defended against consumption became viable food sources when heat neutralized their defenses. This expansion of the edible plant repertoire provided both the nutritional variety and the accumulated botanical knowledge that eventually supported the deliberate cultivation of wild plants. The dietary diversity that cooking enabled reduced dependence on any single food source. A group capable of making tough roots edible, rendering marrow accessible, and processing seeds that would otherwise pass through the digestive system unabsorbed had more options than when limited to easily consumed raw materials. This flexibility was a survival advantage in environments where specific food sources could fail seasonally or permanently, and it was a foundation upon which agriculture could eventually be built. Agricultural societies, when they emerged, built upon a long foundation that cooking had helped establish across the preceding hundreds of thousands of years. The knowledge of plants, the toolkit for processing them, the social structures organized around food preparation and sharing, the biological adaptations to cooked starch and cooked protein, all of these were already in place before the first seeds were deliberately planted. Cooking did not cause agriculture, but it created many of the conditions that made agriculture possible. As early agricultural villages took shape, the hearth moved from the center of an open camp to the center of a home. The fire that had once gathered a mobile band under open sky now gathered a settled family within walls. The function remained the same. The food was prepared, the group was sustained, the knowledge was shared. The social structure organized itself around the flame as it always had. Only the walls were new. The relationship between humans and fire was not limited to what happened within the hearth. Fire was also used as a tool for shaping the landscape itself. Controlled burning of vegetation, practiced across many hunter-gatherer and early agricultural societies, altered the structure of local ecosystems in ways that benefited human subsistence. Burning cleared dense undergrowth and encouraged the growth of new vegetation that attracted grazing animals. In Australia, indigenous populations practiced forms of landscape management through fire that altered the ecology of entire regions over thousands of years. The landscape encountered by European arrivals in the 18th century was in significant part a human creation, shaped by generations of deliberate burning. Similar practices have been documented in the Americas, in Africa, and in parts of Asia. Fire as a landscape management tool was not a local innovation. It was a widespread human practice with deep roots. This use of fire extended its significance far beyond the individual hearth. It made fire not only a tool for transforming food, but a tool for transforming the environment in which food was found and grown. The ability to reshape ecosystems through controlled burning represents a degree of environmental agency that distinguishes human subsistence from that of almost every other species. There is a dimension of cooking that is neither biological nor archaeological, but psychological. The transformation of raw material into something prepared involves a relationship with time and intention that raw consumption does not. Cooking requires anticipating a future state. It requires holding in mind what the food will become rather than what it currently is. It requires patience, attention, and a form of planning that extends across minutes or hours. The regular practice of anticipating and managing the transformation of food through fire would have exercised and reinforced capacities for future-oriented thinking. The ability to imagine a future state, to take actions in the present aimed at producing a desired outcome later, is a fundamental feature of human cognition. The food placed near fire and tended with attention became something better. The future imagined in the act of cooking was reliably realized. Tool making similarly requires planning across time. A stone tool takes shape through a sequence of deliberate strikes aimed at a form that exists first only in the mind of the maker. Hunting strategies require imagining the future movements of prey and positioning oneself accordingly. The cognitive demands of cooking, tool-making, and hunting would have reinforced each other, each contributing to the elaboration of a mind capable of operating across extended temporal horizons. One of the most important consequences of regular cooking was the accumulation and transmission of knowledge about food and its transformation, which plants could be made edible like cooking and which could not, which roots required long exposure to heat and which needed only brief contact with flame. This knowledge was not written down. It was carried in practice, in memory, and in the social transmission of technique from those who knew to those who were learning. Seasonal knowledge became intertwined with cooking knowledge, understanding which plants were available in which seasons, which were ready at which stage of growth, and how to process and potentially preserve them after cooking required both ecological literacy and culinary knowledge. A community whose collective memory held this information was better equipped to navigate the lean periods of the year than one that did not. The transmission of this knowledge required trust and continuity within groups. Elders who had learned through long experience which plants in a given landscape were safe when properly cooked carried information that had real survival value. The social structures that protected and respected this knowledge, that created contexts in which it could be passed reliably to younger generations, were not separate from the technology of cooking. They were part of the system by which cooking's benefits were maintained across time. Preservation through cooking was limited but not negligible. Meat dried after partial cooking lasted longer than fresh raw meat. Rendered fat stored in containers remained usable for extended periods. Fish smoked over low flame could be transported and consumed days after capture. These techniques of preservation extended the caloric reach of successful acquisition events beyond the immediate moment. They allowed abundance to provide a degree of protection against future scarcity. The division of labor around cooking has been a feature of human societies across recorded history and across the anthropological record of contemporary and recent hunter-gatherer groups. The specific forms this division takes vary enormously, but the existence of a social organization around cooking appears to be a near universal feature of human group life. Cooking is labor. It requires time, fuel, attention, and knowledge. A group in which individuals cooperated around the work of food preparation, sharing labor and distributing the results, operated more efficiently than one in which each individual managed their own food in isolation. The social structures organized around cooking were not merely cultural conventions. They represented practical solutions to the logistical demands of feeding a group reliably and efficiently. Who gathered the fuel? Who tended the fire? Who prepared different components of a meal? Who distributed the results? These roles, negotiated and established through long social practice, created the fabric of daily cooperation within groups. They were among the first and most persistent forms of organized collective human activity. The hearth, as a social institution, created roles and relationships that structured daily life in ways that extended far beyond the immediate preparation of any particular meal. The human body as it exists today is not the body that existed before cooking became a regular feature of hominin life. It is a body shaped in significant part by the assumption that fire would be part of its world. Smaller teeth, shorter gut, stronger stomach acid, multiple copies of amylase genes, a brain large enough to require a diet that raw food alone could not efficiently support. These are not accidental features. They are the accumulated physical record of a long relationship between a species and its fire. The brain itself, the organ through which all of human history, culture, art, and science has flowed, may carry in its existence a kind of debt to the hearth. The metabolic conditions that allowed a more expensive brain to develop and persist across generations were connected to the dietary shift that cooking produced. This does not diminish the brain or reduce it to a product of culinary history. It situates it within the full material and biological reality of where it came from. To ask why humans ever started cooking food is to ask one of the genuinely deep questions about what made us human, not because cooking is the only answer, but because it is woven through so many of the answers. It is connected to anatomy and to language, to social structure and to landscape management, to the expansion across continents, and to the agricultural revolution that transformed human civilization. The meal prepared at the end of the day, in whatever form it takes, carries within it the quiet inheritance of every hearth that came before. The warmth of fire, the softening of raw material into something more accessible, the gathering of individuals around a shared preparation and a shared result. These features of daily life reach back across an almost incomprehensible span of time. Across every culture that has ever been documented or studied, the hearth occupies a central place, not merely as a practical device for the preparation of food, but as a symbol, as a gathering point, as a marker of home and safety and belonging. The word hearth shares its root in many languages with words for heart and for home. This linguistic connection is not coincidental. It reflects a long and deep association between fire, warmth, nourishment, and the sense of a bounded, protected space shared with others. The hearth as a symbol appears in the mythologies and origin stories of cultures across every continent. Fire given to humanity as a gift, fire stolen from the gods at great cost, fire tended by sacred keepers whose role was to ensure it never went out. These stories reflect the recognition, encoded in narrative, that fire was not simply a tool but a foundation, that its presence made something possible, that its absence denied. Modern life has moved the hearth to the margins in many respects. Cooking happens in enclosed spaces. Heat is produced by gas and electricity rather than tended flame. The social gathering that fire once required has been replaced by other forms of proximity and connection. Yet the associations remain. Campfires retain a power to gather people in ways that other light sources do not. The meal shared around a table echoes the meal shared around a fire in structure and in social meaning. The warmth of a kitchen, the smell of food being prepared, these carry something ancient that no amount of modernity has fully replaced. To sit near a fire today is to participate in something that stretches back to the earliest identifiably human uses of flame. These feelings did not appear with modern civilization. They were inherited from a time long before cities, before writing, before any of the structures that define the world we now inhabit. If we imagine the entirety of human history compressed into a single day, the period before cooking would occupy most of the morning. The controlled use of fire would appear sometime in the late morning or early afternoon. Agriculture would not arrive until minutes before midnight. The industrial transformation of food production would appear in the final seconds. The hearth, by contrast, has been present for most of the human day. The biological and social adaptations produced by cooking accumulated across a span of time long enough to change human anatomy, expand the human range, and reshape the structure of human social life at its foundations. They are among the most consequential developments in the entire history of the species. The modern world has inherited all of it. The brain capable of designing buildings and composing music and developing vaccines was built in part on the caloric foundation that cooking established. The social institutions through which human civilization has operated carry echoes of the social structures organized around the communal hearth. The agricultural systems that feed billions of people today rest on botanical and culinary knowledge whose roots extend back to the observation of what fire does to food in a landscape struck by lightning. Why did humans ever start cooking food? Because fire was in the world and a curious, flexible mind encountered it. Because what heat did to food was better in ways the body could feel and measure than what the body could do alone. Because the groups that cooked endured longer, traveled farther, and raised children who did the same. And because, over a span of time too long to fully imagine, the body learned to expect fire's help and built itself around that expectation, so completely that the expectation became anatomy, and the anatomy became us. The fire is quiet now. It has been quiet for a long time in most of the places where it once burned every night. But it is not gone. It lives in the chemistry of digestion, in the structure of teeth no longer built for raw flesh, in the length of a gut that expects food to arrive already transformed, in the brain that grew large enough to ask questions about its own origins. It lives in the habit of gathering at the end of the day, in the meal prepared and shared, in the warmth of a space set apart from the dark and the cold, in the exchange of words between people who have come together to eat. These things began long before any written record. They began in the quiet, firelit evenings of a world so different from this one that it can hardly be imagined. They began with the first deliberate act of holding food near flame and waiting to see what it would become. And what it became, slowly, across all the time that followed, was this: the world as it is, the mind that perceives it, the voice that speaks into the dark at the end of the day, carrying old stories into new ears, the way it has always been done. Since the first fire burned at the center of the first circle of people, and the night gathered around them, and they stayed warm, if you are still here, that is enough. And if you have drifted somewhere quieter, that is enough too. The fire is low. The story is told. Sleep well.